So what's the point of all this? This is where it gets tricky. In the backside, you can read. I don't want to insult your intelligence. Let me just explain. In real life, you never just have one charge. In fact, you usually have a whole system of charges. You have hundreds, thousands, hundreds of thousands of charges. Very complicated. We're going to make it a little bit more complicated, kick it up a notch. We're going to have two charges. Here we have on the left a positive source, and on the right a negative source. It's already drawn there. You don't have to worry about it. Now here's what's tricky. How the heck do you figure out what the field looks like around a system of charges? Mathematically, you can do it with E equals kq over the distance squared, and you plug and chug a lot, and you do some sine, cosine, tangent. It's a mess. We're just going to visualize it conceptually. So at point A, I have a positive test charge right here, positive charge here. What would the positive charge do to that positive test charge? It would attract it or repel it? It would repel it. Okay, and the way we can visualize this is let's put on a set of compass coordinates. North is up. What's down? South. What's to the right? East. What's to the left? West. Never eat slimy worms. That at point A, the field vector will go in the northeasterly direction. And I'm measuring with my ruler. It's about 1 centimeter. It's already drawn in for you. I'm just going to color this in so you can see. And this is the force positive. The force positive is going northeast about 1 centimeter. How about the negative source? What's the negative source going to do? It's going to suck this down towards the charge in what direction? Not in the northeast direction, but in the what? Southeasterly direction. And this is also 1 centimeter in length. Why? Because it's exactly equidistant from the 2 point sources. Now I'm going to zoom in so you can see what's going on. And the green, I'm going to switch colors. You guys don't have different colors. How do you add up two vectors? The rule of thumb is you apply what's called the parallelogram rule. You guys know what a parallelogram is? It's not a square, it's not a rectangle. It's a quadrilateral shape where the opposite sides are parallel to each other. This side is parallel to that side, this side is parallel to that side. Then the answer is very simple. The resultant is always where you start to where you end up, the opposite corner. So it's already drawn in for you, but the force resultant, the result of adding up two vectors is another vector. It's an arrow that points not northeast, not southeast, but due east, exactly.